Hello everyone. So today we have an interesting coding problem from LeetCode problem of the day, which is get biggest three rhombus sums in a grid. So let's understand what problem says. So meanwhile you can use this tool for visualizing coding problems, which is DrawToCode.org. It will be helpful for visualization. So let's see what problem says. So what problem is saying, we have one grid of m by n rows and n columns, and we have to find the largest distinct rhombus sums. So three largest distinct rhombus sums. So what that means is we have given one m by n matrix, m rows and n columns. So let's say these are the m rows 1, 2, 3, and these are the n columns. In this matrix, we have to find rhombus and their elements sum. So, and here we can see only one rhombus, but if the grid is large, then we have to find sum of all the rhombus elements and find the which is largest rhombus. So we have to find three rhombus: the largest one, second largest one, and third largest one. First understand what is a rhombus. So rhombus is a grid of diamond shape. So first of all, it has a diamond shape. You can see here this shape is called as a rhombus, and it is formed by four edges. It is similar to square, just it is tilted in 45 degrees. So this is what this rhombus is, and we have to find the sum of these elements, these border elements only. We do not have to include this center element, and we have to calculate this sum, and we have to return the largest possible sum of first three rhombus. So, and these elements also should be distinct. These are the things we have to keep in mind while calculating the sum of rhombus. So as you can see here, rhombus can be of any side as 0 size. If rhombus is 0 size, it have only one element. Here you can see that 5 is the element and size of rhombus is 0. Similarly, rhombus can have one size. One size have 4 elements, which are 30, 4, 40, and 5. Similarly, the largest possible rhombus here is this one, which has size 2 and elements like 20, 3, 5, 2, 10, 4. Correct, 20, 3, 5, 2, 10, 4, 2. These 2 and 4 they aren't included here because we have to find the only distinct elements of rhombus. That's why we excluded these 2 and 4. Or we excluded this 2 number because it is repeated here also. So key observation is that to solve this problem, to find three largest rhombus sum, we have to iterate through this grid and find the respective rhombus. As here we can say that it is a rhombus which has size 0. This is a rhombus which has size 1. So these are valid rhombus with size 0, 1, and 2. So while iterating, we have to find the maximum size possible of a rhombus. Here we cannot draw a rhombus of size 1. By considering this as a middle element, we cannot draw a rhombus of size 1 because it exceeds the limits of rhombus border. So we can see that here it is possible to draw a size 0 rhombus, but we cannot draw size 1 rhombus or size 2 rhombus. So we'll iterate to next. But total sum here is 3. We can see that size 0 rhombus with with sum as 3. We will move to next. Considering this as a center, we will check whether it is possible to draw rhombus with size 1 or 2. So no, it is not possible. So only 0 size rhombus is considered with sum as 4. So 3, 4 and 5, 1, 2. We continue iterating till here. We can say that here it is possible to draw a rhombus with size 1. So what we will do, we will sum these all elements and consider for largest rhombus. So this is that key observation is you have to find the possible rhombus by the basis of its size. This ensures that rhombus stayed inside the grid. Here if we say that size is 1, it is not possible because it will exceed the limit of border of the rhombus. So the basic idea to solve this problem is brute force approach, in which what we will do, we will iterate through each cell. Here we will iterate from 3, 4, 5, 6 like that and treat it as a rhombus center. As I said, this is a rhombus. We will say this is as a center of a rhombus, and is it possible to draw one size rhombus, two size rhombus? We will check that. If it is not possible, then we will move to next. If it is not possible, move next. Next. Here we can say that it is possible to draw a rhombus. So after trying all possible sizes, we will compute the border sum. Then we will compute this A. Let's say this is A, B, C, D. We will sum them all, C and D, and then store the sum in a set. In a tree set, we will use tree data structure for storing this rhombus sum. As tree data structure will store the elements in a ascending order. So as we need only top 3, will be helpful, very helpful to calculate the top 3 elements or top 3 sums of that rhombus. Extract top 3 sums and return them. That's only the problem, and this is the solution. The complexity of this approach is m by n. M is the number of rows and n is the number of columns into minimum between m and n. So most important thing here to understand is how we can traverse this rhombus. So first, here we have to traverse only the border elements. We do not have to consider center element or non-border elements. So what we will do, we will move from top to right with this approach, I plus 1, j plus 1. This plus 1, what that means is, suppose we traversed this rhombus and came to center, and now this will be said as, let's say this is rth row and 6th column. So this coordinates of this will be r comma c. Now what we have to do, we have to calculate the top element. So top element will be size of rhombus. Size of rhombus here is 1. So r minus, let's say size of rhombus is k. So r minus k minus or plus I, and for column, if we want to move to column, we have to say it is a C and plus I. So this way we can find the all possible rhombus elements on a border. So we successfully moved to this point, right? When we do r minus k plus I, r minus k. Minus k is this distance. So we have moved to this element. So we can calculate sum as this element. So one element we got, that is a, plus we have moved to now this element we have got. Now we have to move this element. So for that we have to do plus 1 and plus 1 here. So we have to do these things to move to this position, so that one border will be counted, or we got the elements on a border of this from top to right. Hope you understood this. So we successfully got these two elements. We will sum them, and then we move to right to left, bottom, from right to bottom. To move them there, we have to again, as we got r and c, we will move r plus k. This is k size. So r plus k. Now instead of r minus k, for moving top to right, we will do r minus k. Right? For moving top to right, we do r minus k. But from moving right to bottom, we will do right to bottom. So first we have to go here right. So r plus k. So here it will come as r plus k, and now we will do plus 1 here. So plus I. And for column, we will move c plus k. And here you can see that we are decreasing the I value. To move here, from here, we are decreasing the column value. So c minus I. By this formula, we can move from right to bottom, and cover all the elements which are present on this border of rhombus. Similarly, from bottom to left and from left to top, we will cover all the elements on the border. Hope you understood this. This is the basic and most important point to understand to solve this problem. Next, we will take one example. This is that example. Grid is given in format like this 2D array, and the output is 28, 216, and 211. So these are the three rhombuses which have biggest sum or maximum sum or largest sum. Next, let's see the implementation in Java. So first we have main function with that 2D matrix or array or grid, and we have one function, helper function, which we will call is get biggest 3 with the input parameter as grid1. This one is grid1, which we are passing here in input function. Next, this function is that get biggest 3. Here what we will do, we will iterate through these elements and find their respective rhombus, possible rhombus. So for that, we will move next. We will assign m and n. M as a grid rows and grid columns, and as a grid columns, and then we have defined one set. So this set will store all the sums, possible sums of rhombus. So we are iterating through this rhombus with pointer 0, row 0, and column 0. So this is our current defined as rhombus thing. So we will add that to set. As this is a rhombus of size 0, we will add that in a set. So what we are doing while adding to this function is defined here, add to set. So what exactly we are doing? We are adding that into set, which is tree set, and we are checking whether the set size is greater than 3 or not. We only want top 3 elements. So if we get any element which is bigger or which exceeding this limit, we will pull first element. So here first element will be automatically which is smallest. So our set will remain intact of 3 elements, which are top largest elements. And this set is storing all the sums of respective rhombus. So we have added 3 as smallest 0 size rhombus. Now we will move to next. Here it is a for loop which is checking for size 1. Is it possible to draw rhombus which is of size 1? Here you can see that it is not possible. So what we will do, we will move to, so here are the basic conditions. The r minus k should be greater than 0, r plus k should be less than m, c minus k should be greater than or equal to 0, and c plus k should be less than n. If these conditions satisfies, then we can draw a size 1 rhombus. As here you can see that r minus k, r is here 0, r is 0, and it's calculated here, r is 0 and k is 1, 0 minus k is 1, so is it greater than 0? No, it will be minus 1, so it is not greater than 0. So the condition false, and we will move to next part. We incremented column by 1, so c is now 1, and we will again add this 4 also inside our set. So set is now 3, 4, which is not exceeded is the limits of 3. So after that we will again check, is it possible? Here we will check, is it possible to draw size 1 rhombus or not, by considering this as a center. So you can see that it is not possible, it is exceeding the border. So we will move to next element. So we will see that this is a 0 size rhombus. We will again add this also inside our set, and again we will check whether it is possible to draw size 1 rhombus or not. So you can see that it is not possible. So we will move to next element. Next element, it is of size 0. Yes, it is. So we will add this inside. After adding, we will check is size is exceeding. Yes, here you can see that size is 4. This function, I am talking about this function, add to set. So as size is increased, so the current set will be like 1, 3, 4, 5. So we will pull first element. Now set will be like 3, 4 and 5 only. Right, and we will move to next element, which is now current set is 3, 4 and 5, not 1. Okay, so now we will move to next. Here you can see that we again got element 3. Here also we have already got 3, and here also 3. But as per condition, we cannot include this same elements inside the set. As this is a set, we only include the elements which are distinct. So after this, we will check whether it is possible to draw size 1 rhombus or not. As it is not possible, we will come out of this loop and again increase the c by 1. Now we increased as here you can see that we have reached the column limit. Now c is 5. So what we will do, we will come out of this loop and increase row by 1. Now r is equal to 1. Now we are targeting this element. Now we are targeting this element. So as you can see, R is increased by 1. Now we are targeting, and C here becomes 0. We are again initialized to C, so C is 0 now, and we are targeting to this 3. So this 3 is again, it is not a distinct element, so it is not get added, and also it is not possible to draw considering this as a center. So we will move to next column and we will check here. Now here it is possible to draw one size rhombus. As you can see, 3, 4, 30 and 4. This can be treated as a size 1 rhombus. So we first add 3, try to add 3, as 3 is not distinct. We already have 3, so it is not added. We will then check, is it possible to draw one size rhombus? So yes, it is possible. So we will move inside this for loop and assign sum as 0. So sum is 0 now, and we try to treat this rhombus. So this is a rhombus which we got here. Now we will try to treat it. So first, for iterating, we will iterate from top to right. So for iterating top to right, we will increase I row column also and column row also and column also. So we have got already 4. Now by doing this r minus k plus 0, we will get 4. Now we will move to this. For then we will increment the sum. Now sum will become 0. Sum will become 4. After adding this, here you can see that we assigned the sum at 0 and start iterating this border. So we added sum. Now sum becomes 0, 4, and we will move to next possible border element. So this is the now targeted 4. Similarly, we will traverse all the border elements and respective sum we will get of rhombus. After that, we will add that sum into set. Total sum will be 45. After adding these all elements, we get 45, and 41 is got added. After adding these all elements, we got 41, and we added that 41 inside set. Now similarly, we increased our pointer column. Now it is pointing to this element. R is 1 and C is 2, so it is pointing to this element 4. As 4 is already inside set, we will not add that. We will try imagine to is it possible to draw a rhombus around this 4? Yes, it is possible. As you can see, it is possible to draw a rhombus around this 4. So similarly, we will traverse all the remaining rhombus and we will get total sum of 3 largest possible rhombus. Thank you.